Hello and welcome back to Math with Mrs. Becker. Today we are looking at College Algebra, Chapter 1, Section 5. We will be doing combinations and operations of functions. Just like you can take two real numbers and you can combine them by adding, subtracting, multiplying, or dividing to get another real number, two functions can be combined to create new functions. So for example, if I have f of x equals 2x minus 3 and g of x equals x squared minus 1. If I want to form a new function, I can do that by finding the sum, difference, product, or quotient of those two functions. So here's some examples. If they say to take f of x plus g of x, you are simply taking those two functions and adding them together. As you'll notice, all this is you're combining like terms. X squared is the only variable with an exponent, so that comes first. 2x, I can combine the like terms negative 3 and negative 1 to get a negative 4. If you want to subtract, they said to take f of x minus g of x. The only trick here is that you have to realize that you're minusing something that has more than one term. So this negative has to go to both the x and the negative 1. Negative times a negative is how they got a positive. Then from here, all you're doing is combining like terms and putting it in standard form. Negative x squared goes first, followed by 2x. Negative 3 plus 1 is a negative 2. Product. Here, you can do the FOIL method. First times first, outside, inside, last. Combine any like terms, put it in the final order. Okay, quotient. This just means you would put one function over the other. But remember, if your final answer happens to be a fraction, you have to make sure that you state the domain. You can never have a 0 on the bottom of a fraction. So what they did to get this x cannot equal plus or minus 1, it's x squared minus 1 because it's the bottom. The bottom can never equal 0. So if I add 1 over, x squared can never equal 1. Take the square root of each side. Anytime you cancel a power of 2 by taking a square root, you have to include both the positive and negative. On the other side, the square root of 1 is 1. So x could never be plus or minus 1. That's how they got that. Okay? The domain of an arithmetic combination of functions consists of all real numbers that are common to the domains of f and g. In the case of a quotient, there is further restriction. So what this means is you have to go ahead and look at the domains of the two separate functions. When you combine them, your domain is going to consist of the same domains as the two separate pieces. However, if you have a quotient, there will be more restrictions because the bottom of the new function can also never equal 0. Okay, let's go ahead and look at how this works. So given f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, they want us to find f plus g. Now notice this is just another notation from the way that they showed that above. These two things mean the exact same thing. So I wanted to make sure in the notes that you saw you're just adding f and g. Here, same thing. You're just adding f and g. So if I take 2x plus 1 plus x squared plus 2x minus 1, okay, because that's the f of x function, that's the g of x. Add them together, so we combine like terms, put it in standard form. X squared comes first. 2x plus 2x is 4x. Positive 1 plus a negative 1, that cancels. Now when they talk about the domain, okay, the domain of the original function, this is all reals. There is no fraction, there is no radical symbol, so there's no limitations, it's all reals. This is a quadratic. The domain of every quadratic is all real numbers. Our sum, this is quadratic. Okay, so if I go ahead and I graph it, I have x squared plus 4x. If we look at this, our domain is going to be all reals because this continues to the left and the right. So our domain is going to be all reals. It was all reals for f of x, all reals for g of x. So when I combine the two functions, the domain holds true. Okay, now this is really cool. Notice this. What this means is once you have found a new function, okay, you added the two together. Now they want you to replace the x with a 2, and then you can evaluate. So wherever there's an x, I'm going to replace it with a 2 because that's the number that they're showing me right here. 2 squared is 4, plus 4 times 2 is 8. 4 plus 8 is 12. So f plus g of 2 equals 12. Once you have added the two functions, replace the x with the 2 and evaluate it. Okay, let's look at another one. So we do have the same functions, okay? F of x is 2x plus 1. G of x is x squared plus 2x minus 1. This time they want us to subtract, okay? And notice the f function comes first. So 2x plus 1 minus x squared plus 2x minus 1. Now remember, the trick with subtracting, this negative sign has to go to every piece of the g function because you are subtracting every single term. So I have 2x plus 1. Negative times a positive x squared is a negative x squared. Negative times a positive 2x is a negative 2x. Negative times a negative is a positive 1. Combine like terms and put it in the correct order. The highest exponent is x squared, so negative x squared comes first. X's, 2x and a negative 2x, they would cancel. 1 plus 1 is 2. So this is f minus g of x. It's still an x. Now if they want you to find f minus g of 2, you go into the new function that you just got from subtracting, change the x's to a 2. So negative 2 squared plus 2. Order of operations, this is a multiplying by a negative 1, okay? You have to do your exponent first. 2 squared is 4. 4 times negative 1 is negative 4. Negative 4 plus 2 is negative 2. Now your domain, okay? And that's why they have us, they say graph the new function so you can identify the domain. So I'm going to go ahead and do that. Negative x squared plus 2. Okay, there is my function. Again, it's a quadratic function, so just from even what we learned in Algebra 1 and Algebra 2, if you have a quadratic function, your domain is always all reals, but graphically now I can see that it does continue to the right, it does continue to the left. I can look at the two functions that I used to create the new function. The domain of both of these pieces are all reals. So all together, there's lots of ways to prove that your domain would be all reals. The pieces both had all reals, so when you combine them, it's all reals. We graphed it, it's a quadratic. When you looked at the graph, it continues to the left and the right forever and ever, including all of those x values. So domain all reals, f minus g of 2 is negative 2. F minus g of x is negative x squared plus 2. All right, well, let's look at another one. We're going to multiply them this time. Yes. So 2x plus 1 and x squared plus 2x minus 1. I cannot FOIL because it's not 2 terms by 2 terms. So what I have to do is distribute. So I'm going to go ahead and first multiply every term by 2x. Remember, when you do this, you multiply the numbers and you add up how many variables you have. So this is 2. 1x and 2x gives me 3x. 2 times 2 is 4. 1x and 1x gives me 2x's. 2x times negative 1 is a negative 2x. So I'm done with the 2x. Now I need to distribute a 1. 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 1 is negative 1. Combine your like terms. 2x cubed. 4x squared plus 1x squared makes 5x squared. Negative 2x, positive 2x cancels, minus 1. So that is f times g of x. You multiplied the two functions and you left it as an x. Now, they want you to find f times g of 4. So what this means is now I go here and I replace all of the x's with a 4 and I can calculate it. So 2 times 4 to the power of 3 plus 5 times 4 squared minus 1. So I changed all of the x's. There were 2 x's in the function. I changed them both to 4. Order of operations. You have to perform your exponents first. So if I take 4 to the power of 3, I get 64. So 2 times 64 plus 5 times 4 to the power of 2 is 16. 2 times 64 is 128. 5 times 16 is 80 minus 1. So if I take 128 and I add 80 and I minus 1 from that, I would end up with 207. So 207. Okay, now they want us to graph it and look at the domain. So I'm going to go ahead and get rid of that graph. This time I have 2x to the power of 3 plus 5x squared minus 1. Okay, so this is a cubic function. Again, notice this goes forever and ever to the right. This goes forever and ever to the left. There are no breaks going side to side when we're looking at the domain. So again, this is a case where our domain is all real numbers, which makes sense because the two functions that we multiplied together to get this function, they also had a domain of all real numbers. Let's keep going. Now this one's going to be a little bit tougher. Okay, given f of x is 1 over x and g of x is x over x plus 1. Multiply them, okay? However, I see some domain restrictions right away. Each of these pieces have a domain restriction, and I do have to state them right away because here you can never divide by 0. So x cannot be a 0 because if x was a 0, that function would not exist to even be able to multiply it. So domain, x can never be a 0 because then f of x would be undefined. It would not exist. Okay, g of x has a domain where x can never be negative 1. Because if you put a negative 1 in there, negative 1 plus 1 would end up being a 0. So then g of x does not work. So before I even combine these, it's important to realize that you have to state the domain limitations if you have them, because otherwise the functions would not exist to even go through the process of doing the operation. Now let's multiply them. 1 over x, x times x plus 1. When you are multiplying fractions, this is where you can cross cancel. So this x can cancel this x, leaving you 1 over x plus 1. That, my friends, that is your new function, okay? Then it said, evaluate it if you have f times g, change the x's to a 7. So 1 over 7 plus 1 is 1 over 8. Then it says graph the new function. And I'm going to show you something here. This is kind of wild, okay? So if I go ahead and I graph just the new one, it's 1 divided by x plus 1. So when you look at the new one, yes, I can see that there is that asymptote at negative 1. Now it appears that you can have 0. Well, we can't because in order to create this, we used a function that you had an x on the bottom. So if I put it like this, guys, check this out. I'm going to go ahead and delete this. And sometimes just with domain, this helps. So I want to take 1 divided by x. My bad, there we go, delete that. I'm going to go over, close that. Now open a new one, and I want x divided by x plus 1. And I'm going to go over and close that. Okay, so by doing this, you can see, oh, here we go. Okay, so if I zoom in and I go ahead and tap on 0, can I get it to 0? It will say 0 undefined for you. There we go. Ah, did you see it? I'm not fast enough. There, so now it shows that 0, hopefully you saw that. It shows that 0 is undefined. And the reason why is because you cannot have a 0 in for that first function. Otherwise, you would not even be able to multiply them and create it. So I just kind of wanted to show you that if you're kind of, how do I know what the correct domain would be? You can always go ahead and put the operation. And there we go. 0 is undefined. Okay, so even though I put this in the calculator and all I could see for an asymptote is negative 1, that 0 still is undefined because it would stop the first function from being defined. Okay, let's keep on going. Here are the next ones. Whoa, people, I got some definite domain restrictions. So the domain for f of x, remember you can never have a negative, so x has to be greater than or equal to 0. Okay, I have a domain for g of x. Underneath the radical, 4 minus x squared, that also has to be greater than or equal to x. So if I add x squared, 4 has to be greater than or equal to x squared. Cancel the power of 2. So this side is plus or minus 2 is greater than or equal to x. Okay, now lots of times people are way more comfortable when your variable is on the left side. You could totally rewrite it that way. X is less than or equal to positive or negative 2. Okay, so what that means, remember less than means you shade together the way that we read that really funny back in Algebra 2. This would be a filled in circle and filled in circle for positive 2, filled in circle for negative 2. This is less than, so it's called a conjunction. You shade in between. However, when you go to combine these, this says it can only be 0 and above. So what happens is when we go and combine these two functions together, we're only going to be able to include values that go from 0 to 2, because if it's less than 0, the first function doesn't exist. If it goes greater than 2, the second function doesn't exist. So the only values that you could actually put in when I go ahead and I combine these is anything 0 to 2, including those two endpoints. Now, they want us, find the domain of both functions, did that. Okay, they want us to take f of x, square root of x, over g of x, square root of 4 minus x squared. Okay, now we will have another domain limitation. We already have the two functions separately, but now that's a denominator. So I have to add on the next steps. X can never be what? Well, you square both sides. So 4 minus x squared can never equal a 0. If I add x squared over, 4 can never be x squared. Take the square root of each side, so plus or minus 2, x can never be plus or minus 2. So now it takes off that piece. It can start at 0, now it can go up to 2, but it can't be a 2, because if it's a 2 and this is on the bottom, then you're dividing by 0. See, it's kind of wild, you guys. Next one. If I take g of x, square root of 4 minus x squared, and I put that over the square root of x, okay? The domains together looks like this. When I had f over g, okay, when I had f over g, I could no longer include the 2. Let's see what happens here. I have the domain for the separate pieces, but here, this can never equal a 0. So x can never equal a 0. So on this one, I can include the 2, but not the 0. So just kind of really bringing those domains together. When you're finding the new functions like f of x over g of x, you're simply just putting one function over the other function. If this is g of x over f of x, you're just putting one function over the other function. That's it. Okay, let's look at the next one. Given f of x is x over x plus 1, and g of x is x cubed. I do have a domain limitation. X can never equal negative 1 because then this function would not exist. They want me to take f of x, x over x plus 1, and divide it by g of x. Well, if I look at this, this is a fraction divided by something else. I can turn that also into a fraction by putting a 1 underneath it because we cannot divide fractions. So what I do is I keep the top the same, x over x plus 1. Change divide to multiply, flip the second one upside down. When you are multiplying fractions, that's when you can cross cancel. So I can cross off this 1x here, and now this would go from 3x's to 2. So your new function would be 1 on the top, x squared, and x plus 1 on the bottom. Now this added more pieces to the domain. I know that x can never equal a 1, a negative 1, because this piece would be a 0. But now with this on the bottom, your x can also never be a 0. Okay, let's look at one more. Here are my two functions. 2x minus 5, domain is all reals. That's a line, no radicals, no fractions, so that's good. G of x, 1 minus x, this is also a linear function that has a domain that's all reals. So no limitations right away. Take the f function, 2x minus 5 over the g function, 1 minus x. There's your function. What is the domain? Well, now that my final answer is a rational function, meaning it's a fraction, I have to know that the bottom can never equal 0. I can go ahead and add that x over. So 1 can never equal x. And that, my friends, is the first part of 1.5. I know the domain part gets a little bit tricky. It'll get better with practice. Otherwise, you are just combining functions by adding, subtracting, multiplying, and dividing. Tomorrow when we get together, we will be doing compositions of functions. Have a great rest of the day.